plus 2 is a factor of 12x cubed plus kx squared minus 13x minus 6. Write down an equation satisfied by k, hence show that k equals 19. So let's call this equation here f of x. The factor theorem tells us that if I do f of minus 2, so f of whatever negative this constant inside the bracket, that will be equal to 0. So I can set up my equation this way, so I can put f of x, which is 12x cubed, plus kx squared, minus 13x minus 6, equal to 0. At this point, I want to actually substitute in the x value minus 2. So I get 12 times minus 2 cubed, plus k times minus 2 squared, minus 13 times minus 2, minus 6 equal to 0. Notice that I haven't substituted in k equals 19. The fact that it's said to show that k equals 19 means that I have to set up this equation and solve it as if I don't know k equals 19. K equals 19 is given so that the next part of the question can be answered if I can't answer the first part. Working through these terms, minus 2 cubed is minus 8 times 12 gives me minus 96. Minus 2 squared is 4, so I get plus 4k. Minus 13 times minus 2 is plus 26, and then minus 6 equal to 0. If I tidy up the constant, plus 26 minus 26 gives me plus 20. Minus 96 plus 20 gives me minus 76. So what I'm going to do is I'm going to add 76 to both sides of the equation so that I get 4k equals 76. Now I can divide both sides by 4, and of course when I divide both sides by 4 I get k equals 19 as required. How are the marks given in this question? Well, the marks are given in this question for setting up and using that equation. Apologies, that's not an accuracy mark there, that is a method mark given for setting up the equation and substituting in minus 2, and then the accuracy mark is given for a convincing argument, so working through and demonstrating that k equals 19. That was part A. Part B wants us to factorise 12x cubed plus 19x squared minus 13x minus 6. What we know is that x minus 2 is a factor. So I've got x plus 2 is a factor. Now, what I'm looking for here is I've got some sort of ax squared. I'm looking to find a general quadratic. So if I consider multiplying x plus 2 out with some sort of quadratic to get our cubic, what I know is the 12x cubed must come from x times ax squared. So this term here must be 12x cubed. And so x must multiply with 12x squared. Otherwise I can't get the 12x cubed. That means I can fill in this column because 12x squared times 2 is 24x squared. Now, I want to get 19x squared. So if I've already got 24x squared, that must mean when I do x times bx, I'm going to get minus 5x squared, because these two terms will have to add up to 19x squared. And that means I'd have to multiply x by minus 5x. Filling in my column again, 2 times minus 5 gives me minus 10x. Now, I've got minus 10x. In fact, what I want is minus 13x, so that must mean in this part here, when I do x times the constant, I must get an extra minus 3x, which means my constant must be minus 3. And so what I want to just check is that if I do plus 2 times minus 3, do I get minus 6? I do get minus 6, and this has all worked out. So now I have my quadratic, and we can say that 12x cubed is equal to x plus 2 times 12x squared minus 5x minus 3. Now it says I want to factorise this fully, So I need to factorise 12x squared minus 5x minus 3. 12 times minus 3 is minus 36. Factors of minus 36 with a difference of 5 and 9 and 4. So I'm going to be 12x squared plus 4x minus 9x minus 3. Factorise my first two pairs of terms. I can take 4x out, so I get 3x plus 1. Factorise my second pair of terms, so I can take a minus 3 out, and I get 3x plus 1. And so then, taking the 3x plus 1 out as a common factor, I get 3x plus 1, 4x minus 3. And so what I need to just state at the end then is 12x cubed minus plus 19x squared minus 13x minus 6 is equal to the first factor I was given in the question, which was x plus 2, multiplied by the rest of the factors which are found through the process of factorisation, so 3x plus 1 and 4x minus 3. How are the marks awarded in this question? Well, you get 1 method mark if you get 2 out of the 3 terms correct, and you get an accuracy mark or answer mark if you get all 3 terms correct. Finally, you then get an answer mark if you have factorised that quadratic and then stated that the cubic is equal to the 3 brackets we have now found. Let's look at part C. Part C says find the remainder when 12x cubed plus 19x squared minus 13x minus 6 is divided by 2x minus 1. Now, what I can do is I can use the remainder theorem, which states that if f of a equals to some value, that's the remainder when we're divided by the brackets. So the thing to do is find out what do I need to substitute into my function. 2x minus 1 equals 0. If I solve this, it will lead to the fact that I want to use the value x equals a half. So I'm going to do f of a half, which will be 12 lots of a half cubed minus 19 lots of a half squared minus 13 lots of a half minus 6. So a half cubed is an eighth. 12 over 8 will give me 3 over 2 minus a half squared is a quarter, so I get minus 19 over 4 minus 13 over 2 minus 6. Let's put them all as quarters. So double the 3, I get 6 minus 19, that's already a quarter, minus double the 13, I get 26. I need to have 4 times the 6, which is 24. This is plus 19, so that would be helpful putting the plus, otherwise I've got a silly mistake coming through there. So I then put this all over 4, so I get 25 minus 50, which gives me minus 25 over 4 is the remainder. Okay. Now, let's look at how we get the marks in this question. If in some way you have attempted to substitute in a half into the expression, you get a method mark, and then you get an answer mark if you've managed to persist and find the answer is minus 25 over 4. I hope that all made sense and that you were able to understand what we were doing there.